Hi.
Hi.
Yes.
So can you see the screen?
Yeah.
Okay. Until now, like we have seen the static method, seismic analysis.
Yes.
Okay. Now, like we are into dynamic analysis. Okay.
Dynamic. Okay. So that's the vehicle load. Everything are dynamic analysis.
No. That I will come one by one. Like today, we will see like dynamic analysis. So few things. Then I can tell you. So vehicle load, it was different. It was coming under moving load. Okay.
Okay.
So I will
The reason why
create
I'm
one
asking.
structure.
Okay.
Okay. Just peculiar name so that it will not disturb the other files. So I can use a structure wizard to create our structure.
Okay.
Okay, so why not we can consider like easy, for example, I can consider 4, 4, and here I can consider 6, 18. So 1 and then 6 and then 1. So apply.
Okay.
Okay, this one and close and then import back. So now I can go to the fixed support.
Okay.
So properties. So define. So now I will consider the same. Okay, both point 3, point 3 better.
Okay.
Assign to the view. So until now you are okay with. Now like I can go for loading. Okay.
Yeah.
So I will tell you the other things in the definition later. Now the
Okay.
basic dynamic analysis I will tell you. Okay. Load
Okay.
case detail add. Are you there?
Yeah, I'm here.
Okay. Actually here like you can go with the seismic. So
Okay.
otherwise none also doesn't matter. Okay. Now I can consider load case X, then
Okay.
load case Z. So X and Z. Mostly
Okay.
seismic in the sense like it will be like lateral loads, that's why.
Yeah. Okay.
And then I'm adding. So without definition, now we are going to do the dynamic analysis or we are going to find the frequencies. That's why you can see now.
Frequency. Okay.
Yeah, in this Rayleigh frequency and then Egan extraction method. Okay, both we will compare how the values are similar or different. Okay, actually it's supposed to be similar. Okay, now like
Okay.
what we are going to do self weight and for this frequency and all, now if you're putting a negative value, like the software will get confused. So what we can do? So for x, right, I will consider x in one factor.
Okay.
Okay, and member I can consider something like 10 kilonewton meter. So this you can consider whatever the way you want. Okay, this
Okay.
also I can put it as gx direction. Okay,
Yeah.
okay. Then like floor load, I will put a floor load of some 3.5 or 3. I will consider 3 and global x. And we know now we gave 18. Why 18, right? 18.
Yeah.
Okay, then we'll see how it came. See, assign to the view. So this one, yeah, it was a floor load came correctly, x direction. And this one also assign to the view.
Actually, floor load will be in vertical, correct?
No, but for frequency, for finding frequency, you should not use negative and you should not use the uh, like downward or upward things. You should use the lateral loads.
Oh, okay.
You understood? No, you should not use anything apart from the lateral loads. Okay. Then like
Okay.
I'm going to add the frequency Rayleigh method, Rayleigh frequency. Okay, add. So this is not a load actually to find something in the output. You know, that's why we are putting it like a command. But it was here itself in the load case. Okay, now
Okay.
again I'm adding the self weight, but Z you should not use vertical loads. That's why that too
Okay.
you should not use. Okay, then member load again we can use 10 itself, but Z. Okay, and then a floor load. So the same 3, but 18. But here it's supposed to be GZ.
Okay.
Assign to the view. So assign to the view. Okay, now you can put that calculate Rayleigh frequency.
Okay.
Okay, now what you need to do means like go to analysis and design, and you can put the command. So you just add it, perform analysis and run analysis.
Okay.
We'll see the values in the output.
Okay.
View output file done. Okay, and you can scroll, and can you see here we got Rayleigh frequency for loading 1, which is in X direction, and loading 2, which is in Z direction. You can see the cycle per second, which means like 0.56469.
Yeah.
Okay, and you can see the maximum deflection of 99.4 centimeter at joint 14. And
Okay.
here for the second load conditions, like a joint 27, joint in the sense node numbers.
Okay.
Okay, both
Yeah.
showing the same because it's symmetrical structure, right? Both way. I think if I'm using 4 and then 8 in another length and width, if it is in square only. That's why both same we got.
Okay.
Okay, this is a kind of dynamical analysis we can say for seismic things. Okay,
Okay.
cycle per second we are getting, right? Okay, which means like we need to divide 1 divided by 0.56469. No, I think 0.5. Yeah, cycles per second. It was okay, CPS.
Yeah.
Then you consider, can you take the snapshot of this? Like we will compare this with the second method.
Okay, 1 minute. Yeah.
Okay. Okay. Now, like for the second method, I will close this one. Better. Maybe if we are editing something in the input file, maybe something wrong happened. We might be not aware of. Anyway, again, the
Okay.
same structure we will create.
Okay.
Um, New.
No, my doubt is
Yeah.
where we can use this analysis method. For example, the vehicle load
Yeah.
that for the OT overhead crane, EOT
Yeah.
crane.
For gantry girders or something like
Yeah,
that.
there we can use the vehicle load method,
Moving loads. Yeah.
moving loads. Yeah. So like this
Hmm.
where we can use it in practically
No,
or
we are
in
finding, see, seismic analysis, why we are finding? We are finding base shear and time periods, right?
correct.
And that's why here also we are getting maximum deflection. With this, like we can study any structure. And you said, you want to know like time history analysis and all, response
Okay. This is
spectrum analysis.
this is time history.
Yeah, no, response spectrum analysis and also there. So for this, like it is like a correlated.
Okay, 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 okay.
Okay, before I put STR 0.
Response spectrum analysis during the blast condition, it is required.
That's why like that also we will see later. Now we are just finding the basic frequencies using two methods, Rayleigh and
Okay,
Egan extraction method. Okay.
okay, okay.
Okay, I think might be I need to change it in the before itself, but now I will consider the same thing so that we can consider the values.
Okay, okay.
As usual, fixed support. That too, for this kind of analysis, you should have fixed support.
Okay, okay.
So same I will put here also better.
Okay,
Okay, okay. So if you want, like, you should not consider the vertical. Actually, we can consider also in this method. Okay, but what I
okay,
can do means like loading. Again, I will add only one load case.
okay,
Okay, load case only one. Okay, okay. In this, like, we will put all those. Like whatever you put separately there, we will put everything here.
okay,
Okay, but before that, like, we need to put some modes and all. Okay.
okay,
Okay, that like you can find from analysis and design miscellaneous command and then cut off mode shape. And you can see by default STAAD itself like having six mode shapes. It's more than enough. That's why like initial 5 to 6 mode shapes, it's more than enough to analyze any structure for dynamical analysis and all. Okay,
okay, okay.
so we can
Mm,
put 10 for this. Okay, for example.
okay,
Okay, then like I'm going for loading. Now we will add.
okay.
Again like x1 z1, so these two only we added, right? Okay, then like a
Yeah,
member of 10 in gx and then gz. Okay, and then floor load we added 3 right, gx,
yeah, yeah, yeah.
gx and then y maximum 18,
18, 18.
and then gz also we added. Okay, okay, this we confirm. Okay, okay, then all this assigned to the view. But if you want like vertical also you can put separately. But I just taken later loads. Okay.
Oh, that dead load, vertical dead load.
And not dead load. Now, yeah, that's why like a negative you should not take. Anyway, you will get. Anyway, you try when you are doing. So let me know like is that possible to get or not. Okay.
Okay,
In this methods like we never use negative. That's the thing. Okay. And
okay, okay.
okay, load cases we completed. Then
Yeah, even
analysis.
for seismic analysis also, negative load is not considered.
Ah,
Okay,
okay. So add. Okay. No, but like we need to, I think we need to put the load something. Wait a minute. Oh, we didn't put that frequency at all. After all, that is important, right?
okay.
So
Yeah, the
frequency and then model calculation.
model.
Okay, eigenvalue extraction method. The people who invented, that's why this name's eigenvalue, Rayleigh and all. Okay.
Okay, okay,
Okay, model calculation requested. That's it. Okay, we will see how to analysis and design and analysis. I hope we will get the result. Anyway, this is the first time. I just tried it before only. See, one error. Eagle value I didn't try, so I just ask you to connect. So what is the error? Density not provided. Sulfate command ignored. We didn't provide density. Oh, okay. Might be why
Density, no, we didn't do
property.
it.
This assigned to the view I didn't do. Okay,
Oh,
I think it's going to close. What happened? This I just created. Oh my goodness. I don't think so. It will come again the same file. Wait a minute.
and it will come, no, we are done. Okay.
Okay, because we got analysis also done.
Mm.
We forget to put that to assign to the view 0.3 cross 0.3. Yeah, this one. Okay. Okay, the properties we'll see whether we know nothing came. Okay, we need
Before
to.
it didn't.
Yeah, I think that's why after analysis, assign to the view. Maybe everything also we need to do it again. I don't think so. It was there. Okay. Everything else there. Okay,
Except
analysis.
that
Yeah,
assigning, yeah.
run analysis. I hope it will
Okay.
come. Otherwise, we need to change the sequence or something like that.
Okay.
What is this? Advisor. Okay, view output file.
0.
Zero error. See, Egan solution.
Yes, yes.
You can see 0.567. I think the same we got na before. Can you refer? Can you send it to my WhatsApp? I
Yeah,
can
yeah.
check also. I
Uh,
think first and second itself like giving the same cycles per second and period, which is called 1 divided by 0.567. You will get that one 1.78 inverse of cycle per second. Can you
yeah,
send
yeah, yeah.
that screenshot to me? I can also compare here.
Yeah, 1 minute, 1 minute or something.
And you can see here 10 modes we got, and the mass participation factor is very important. See, in this mode 3, we are getting 000. That's why,
Yeah,
like, initial 4 to 5, it's enough. Like, see, another 4th and 5, and we got a participation factor in percentage.
yeah, yeah.
That's why, like, initial by default 6 we got. So, whatever here you have 52 plus 29. So, 81 here it will be. And then, see, 81 plus 7. It's a summation of X, Y, Z. This it is in percentage. Okay, you send it.
Oh, yeah, send just now.
See 0.564 na, but in this method we
Yeah,
got 0.561. Yeah, okay, cycle per second. But if you're dividing one by this number, you will get this one. That is time period.
0.56 divide.
No, 1 divided by 0.567.
1 1 0.561. Okay.
You will get 1.78 at 253, but here 1.78348. Okay, it's no issue. Maybe here we
Okay.
might be not aware of the exact numbers,
Okay. Okay.
but 1.78 seconds. Yeah.
Mm.
Okay, this two frequencies you are okay with, na? So
Yeah.
this to
Yeah.
study the structure for thing. Okay, but I will show you the post processing.
Okay.
Okay, the post processing. Click OK. See, you can see for mode one and mode two, mode three, mode four, mode five, mode six, mode seven, mode eight. No, but why it was not showing anything? Wait a minute. Mode shape. You need to click mode shape, not the deflection. See, mode 8, it was like this.
Okay. Okay.
Okay. Wait, one by one we'll see. First mode, okay. Second mode. See, third mode. So it was like a torsional kind of thing. Okay, effect. The fourth mode, that's why like for the third mode, 000. But for fourth, fifth, see, again for this also torsional. That's why it will be like cancel, I guess. See, I think
Okay.
6000 might be, then
Yeah.
3 also 00 might be. So rest of the things and all like again 9 also 000, 10 also. We will see that one here. Where is the
No,
output file?
no, for this load, whether the structure is pass or fail, how we can find?
No, that like we can do from the design only. This is to study the response for the dynamics. See, you can see that we are just analyzing in a dynamic mode, not static mode. That's why modes and all like we are getting mode shapes and all. And see, I can also show you the dynamics. In
Okay.
this dynamic, like for mode 10, it was showing control, and then the same way control scroll down to reduce the sizes. Okay, and
Okay.
you can see the same only we seen in the output file. How you remember? See,
Yeah. Yeah.
0.561, 1.78 participation
Yeah.
factor. See, for the third one, there is no participation factor.
Yeah.
And
Yeah.
for mode 10, see, because these things you can see here itself, like mode 10, 000 might be.
Okay.
Mode 9 also 00, but for mode 8 you will be having some participation factor. See in Z
Okay.
axis 3.01, and here you got more participation factor for a mode 7, something like that. Yeah, again 0 it seems to be, again like you have, yeah, but for here also 0, but for this like you have a 52.62 percentage in Z, and also X also you have. And for the see the same value you are getting shuffled because it's in a square shape. That's why 52 here, 52 here, 29
Yeah.
here,
Yeah.
29 here, like that.
Yeah. Yeah.
So these things we are getting based on the self weights and loads applied, and you can see the
Okay.
frequencies and time periods.
Okay.
Okay, and animation in the sense like for mode you can able to animate also.
Okay.
Hmm. This is mode 1, right? Mode 2 also you can animate. For mode 3, we can see,
16.
yeah. So this is for mode 4
Mm-hmm.
and mode 5. It was like this. Mode 6. See, whatever you are seeing, it is in a animation, nothing more than that.
Yeah. Yeah.
Mode 7. Okay, mode 8. Okay. That's why initial mode 6 only, like by default we are having in STAAD Pro, but we put 10. Okay. Now you got this one. Like if you're okay with this, like for a response spectrum analysis, no need to put these commands like Rayleigh or a eigenvalue. You can directly go for response spectrum analysis.
Mm-hmm. Okay.
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 Next we
No,
can
no.
see the
My
response
my
spectrum
concern is
analysis.
no. My question is, what is the limitation? Is there any limitation to check? That is the concern. For example,
No, you were asking about the values and all, right?
yeah, is there any, I mean, checkpoint is there, whether I need to, this member is maybe this building or this response method, this
Okay.
building is adequate or not. If
No,
the
no, no.
blast, for example, there is a blast
Hmm.
hitting the building,
Hmm.
the building should not collapse.
So that based on the concrete design you will get, na? So not now. Now you will get based on the like loads assigned and based on the property like you are getting. So whether the members getting pass or fail and all like we can see later. Now the next one like we will go for response spectrum analysis as a continuation of this frequency. Then I can
Okay,
tell you the time history analysis and all.
okay.
Okay. For response spectrum analysis and all, you should not put these frequencies and all. For that, like you need to put the seismic definition. When you are putting seismic definition and all, like these frequencies and all not needed. It will be automatically taken. Okay.
Okay.
Now you understood the Rayleigh frequency and Egan value extraction method.
Yeah.
Okay. I will close this window, this file, and again I will open a new file where also we will analyze the same structure, same dimension for the response spectrum. Okay.
Okay.
Okay. So new str03. Okay. Then create. So structure wizard, frame models, 418 and then 4161 apply. Okay. Close. Yes. So assign to the selected nodes.
Mm.
Okay, so view is the same thing. Okay, now like a cross section, important property. The same 0.3.3 we will put. Since concrete, na, so based on that, the densities and all, it will be considered. Assign to view. Okay, then like we can go for loadings. Okay, then loading, I will, okay, wait a minute. Now we are going for response spectrum analysis. Okay, for that like seismic only.
Okay.
Okay. Then like what we can do means like 1893. You can consider whatever you want. Like this we know na as per the Indian standard 1893. But like
Okay.
normally like what we will be considering UBC code only, right?
Yeah.
Okay, this whatever you want, like you can put it there, and you can
Okay.
change the zone and all this factors and all if you want.
Okay.
Again like it was coming with this thing, this one wall area and all not needed. We can go for self weight factor of 1 I will put. Okay, see this is what seismic and all self weight, it's 1 only factor, not negative. Okay, then like we
Load
can go
weight.
for member weight and floor weight. That's what we considered before also, na. So concentrated, not unit. Then 10
Okay.
kilonewton meter. Okay. But member weight, okay, 10 only. Okay, then like element weight or floor weight we will consider. Okay, floor weight of 3 only we consider, right? Y range of
Yeah,
maximum 18. Okay, and here like that's it. Okay, this like assigned to the view.
okay,
Okay, everything else we got. Now like we can go for a primary load case.
okay,
Okay, better we will seismic of X and then EQ X add, and
EQZ.
EQ Z also we will add. Okay. Now through the definition we are coming. Before we are doing separately. So that's why like here we can go for X only one factor.
Okay,
Okay. Then here Z only one factor. Okay. Now like a command analysis command and we can run the analysis. Okay.
okay.
So add it. Then run analysis. If you want to print all, you can put print all. Otherwise, like yeah, for these things like not needed print all.
Okay, okay.
Now like we will see the like time periods.
Yeah,
This is the static method we always used to do.
yeah,
Okay.
this is the seismic, yeah.
Yeah, the static normal method. Okay, anyway, we'll see the value just to capture that one. Can you take the screenshot of it?
Yeah, yeah, 1 minute. I will, yeah.
Base shear and time periods we are getting now. So that like this is static analysis, then we can go for a dynamic analysis.
Yeah,
Okay.
I took.
Okay, so I can close this. What we can do, just I will go to the utilities and command file, and I'm going to deactivate something, load 1 and load 2. Load 1 and load 2. Okay, load 1 and load 2. Uh, why? Wait a minute. Load 1 and load 2, I will comment it, which means like deactivating. Then, yes. Now, like
No, there is no.
now we will add the cutoff mode shape for the dynamic analysis.
Okay,
So cutoff mode shape of see by default 610. Okay. So now we will create another load case. Okay, for our dynamic things.
okay,
Okay. Wait a minute. Okay. Uh, since we have definition already. Okay, all these things. Okay, add. No, what is this load case detail? Add. Why it was coming load case detail?
no, no, there's no load case.
No, no, no. When
We we
yeah,
disabled
now
them.
okay, okay. Now it was like coming. So now like what I will put means like okay, I think here we have anything seismic only, no? So we can put a response spectrum.
Okay,
Spectrum. Okay, response spectrum. Close. That is the name of the load, and then we can add it. Okay, now like we consider X and Z only, right? No, I think so here like you need to consider everything because like through definition we are coming.
okay,
So X, Y, Z we will consider and then the member load also. Uniform force of 10 we consider.
yeah, before consider 10.
Okay, 10 and then GX, GY, GZ. GX, GY, GZ. Then like
Okay,
we can go for the this one. The floor load. Floor load we consider directly like a 3, right?
sorry, yeah, yeah.
Yeah, 3 and then
Maximum 18.
18. Okay. 18 global X and global Y. Not one-way distribution, so no need to worry about that. Gx, Gy, Gz. Okay. Then these things assigned to the view. Will assign to the view. Okay, and then assign to the view. Okay. Okay, now like in the same load case, include the response spectrum. Okay.
Okay.
So again, add. See response spectrum. Okay, so here we have something like this. So here you can choose like whatever you want. So we choose. So do you have any preference? Like Indian codes, Euro codes, IBC, everything. Like we considered.
Like to the IBC
Yeah.
2015.
Okay, 2015 we will consider.
Yeah.
And the combination methods also we have so many things.
IBC, ASE.
ASCE, okay. Okay, and then like here this value and all like we can able to put whatever we want. Okay.
Where can we see the how it's already default value 8.8 and 0.8.
Yeah. So you need to consider the particular code book. Once you just download and you can refer the particular page and you can get all these things. And the site
Okay.
class, based on the site class. If I'm putting site class D, then you can see here it was changing. So you need to consider
Okay.
the particular code book. So we
Okay.
can't by heart all this. No need to worry. You can refer the particular code books.
Okay. Okay.
Okay. Then everything once you are okay with it, then like you can able to add it. That's it. Like actually, there's so many things there, so you can modify or you can try with so many, and you can see the results. Now, like I told you the things.
Okay.
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 Now, like we can go for analysis. I think I ordered already. No, I think no. Analysis command and add. Okay. Now, like I can run analysis. Since we put mode 10 modes, now we'll see the mode shapes.
Okay. One error is there.
What is the error? Analysis cannot be performed since no load cases have been specified. Where it was telling no load cases have been specified.
No, we gave the spectrum response nothing.
Ah,
Here
since no load cases. Okay, no load cases, why it was coming. The meeting is going to end. You can join back after 10 minutes, okay?
Okay. Okay.
Ah.
So these are load cases, correct? That
Load cases only.
and why it is showing into no load cases?
Wait a minute. We need to check somewhere some mistake with it. This one seismic only, right? No need to worry then.
Mhm.
Maybe we need to deactivate the seismic definition also because we are putting here directly. That's why.
Okay.
Okay, so you can join back and we will try like putting this also like.
Hi.
Okay. You are back, right? Okay,
Yeah.
like we deactivated only the load one and load two, right? What we will do, we will go back to the. I didn't check actually. I will check now.
No,
Uh,
we discussed to deactivate the load definition, the seismic definition.
yeah, we will deactivate now.
Okay. Okay.
That's why, like, without showing you, I didn't do anything. So in this 10 minutes,
Mhm.
wait a minute. Define UBC, right? Okay, because we are not using these things. Okay, then that also comment. Okay, then yes, because we
Okay.
have everything in the response spectrum load itself.
Yeah.
Now we will analyze. I hope it will come. There is one error. Why? Analysis cannot be performed since no load cases.
Okay.
Why no load cases? It's coming. Okay. Okay. All this like UBC and all. We just.
No, the load one, load two is there already. Load case one, two is there. Seismic load one, load two.
No, this one like no. This is like
Sorry. That is okay. Disabled.
okay. Cannot be performed since no load cases. No load cases. Load case in the sense, yeah, not load combination. Load cases.
Yeah, we have the
Yeah.
one, the response spectrum. So this is the load case, right?
Yeah. Load case only. So, okay. What if I'm putting none? Now we'll see analysis and design. Something changed when I changed to none.
We're doing two times perform analysis. That's why
Maybe because of that. Oh, okay. We'll see. So what we can do, one, we will just delete this one. Maybe now it might come. Sometimes this will show error, but without knowingly or unknowingly. Might be now it will come. No, it's not coming. Perform analysis doesn't matter, I think. Maybe I made a mistake. You taken snapshot, now maybe separately without. That's why command, if we are putting like this, it may come like. So two error. Okay, okay. CQC will be used instead. You said AAC, na? CQC we will use. Okay. Maybe
okay.
performance analysis. Okay, loading. Okay. So in this like edit. Uh, okay, you click edit here itself. Huh? Okay. Edit. Okay. So not a CQC. Okay, CQC. This is what it was telling. Okay, damping ratio and all 5. Change. Okay, close. Now we will see.
Okay.
I think it will come because we used to CQC now. Mostly for this, no. I think another error. Hmm. XY as a parameter is not entered or out of order. See here it is telling some manuals and all. We can refer that also.
Okay.
Okay. So GX, GY, GZ. Okay. 18 meter. Okay. Flow
No,
load,
XY is
yeah, out of
what?
order. XYZ. Here it was correct. GX, GY. Okay. Load. We will go back to the load.
The self height, if any direction, it will be one, correct?
Yeah. Okay, I will delete this and I can put it again. Huh? Okay. Now we will see only with this like what we are getting, huh?
Okay.
Without any response spectra. If it is coming, then there is no issue with it. Zero error only we are getting. Okay. Then maybe in the problem in the response spectra. Okay, which means like whatever we are adding. This load case we named it, but it doesn't matter here. Add show response spectra. Okay, the custom. So I think what if you are considering here? No, we didn't consider it. That's the problem. IBC. We need to consider the direction. We didn't consider that. Okay, and this one ASC also okay.
Yeah, I will consider ASC.
So X and Z, we didn't consider that one. We need to put factor 1 and 1. Maybe
Okay.
this is what like it was telling. Okay. So we can add it. Yes. Okay, close it. Now I hope it will come. Maybe, yeah, I think seismic definition also not needed. Na? Okay. Yeah, now it's got. So there you need to put the X and Z factor. See, for this and all, it is automatically coming. We are not putting that. Response
Yeah.
spectra, it is coming automatically. That's what like I told you separately we can see and then see cycle the same values coming. You can see now. So that's what
Yeah.
like all methods. Okay, so response spectrum load you can see and then see this one what it's important. Modal based actions. So this periods and also for 10 modes you can see the force and then which means shear force and bending moments.
Yeah.
Participation factor. And can you check the shear? Can you send the snapshot you taken in the static
Yeah.
so that like here we can study. So both x and z coming same value since it is like a square symmetrical structure.
Yeah.
But for different methods, CQC or SR, SS and all like different values we are getting. Okay, we will check.
Yeah. Sent to you.
Okay. So here, like how much, it was like a base shear 72.74. Okay, so okay, 2, 3, okay, 72.74. The static thing is coming lesser than the response spectra.
72 point.
Yeah, that is only the, but here you can see it is like 372 until 807 we are getting.
Yeah.
Yeah.
SRS. So which means that how we can validate this result is correct?
Okay, wait a
No, this
minute.
result is okay.
No, not result is okay, but like here we are getting a base shear which is like larger than the static method. So static method values lesser than the response spectra method.
Yeah, correct. Yeah.
Okay, so that I will tell you it is like safe or not. Hello.
Yeah, yeah.
Okay, actually, this could be because of the reason, but here you can see now, Egan solution, we got the same 0.561 and I remember 1.78. Okay, but
Okay,
like
okay.
participation factors, and you can see the value here, which is like more than the static method, right?
Yeah,
So
yeah.
because of the reason, whatever we are inputting here, so here we are inputting na the response spectra. So in that, like we modified na some X and Z also now. Similar to that, like you need to modify the damping ratio and all, and so that like it will vary. So it doesn't matter. So what we can do, it's actually a very small structure, what we consider. So for this kind of
Okay,
thing, like static method itself, it's enough. Like with that itself, like and we can continue. But if it is like a very huge structure and if it is like very complex, then we can also take the values from the response spectra for safer side. But for
okay,
small
okay.
structures like a response spectra, whatever we got, that might be not economical. You understood the concept now.
Yeah, yeah.
So once we change the things here and see here also site and all, it's there because of that. Maybe that much difference.
Okay,
Okay.
okay.
Now you need to consider if it is like a simple small structure like static analysis and those result itself enough. If it is like complex and huge structure, uh, like this kind of response spectra, this output also the base here you can consider.
Okay, okay.
Okay. So this participation factors here. Okay. Which is like 72, right? But here it was 80, so 10 times more than that.
Yeah, yeah.
Okay, that two different things they were putting here. But here you can see, no, that was different. Yeah, so here also it was like sometimes 77 and 32 also.
Yeah.
Okay, but it is like adding up. I told you, now this is summation 52 plus 29, 81. And then 81 plus 3, 80, 81 plus 7, 88, 88 plus 4, 92, like that it will go on. So that like
Okay,
100 it will come totally.
okay, okay.
So we consider X and Z only, not Y. That's why. Lateral load. See, ectopic in the sense base shear it will come only in X and Z. That's why.
Okay, okay.
So today, like you understood like the difference between the static method and dynamic analysis. In that, like what are all the things we see in Rayleigh frequency and Egan extraction method. Now,
Yeah,
like response spectra also we have seen.
yeah, yeah, yeah.
Okay, then only like we can go for time history analysis as a continuation of it.
Okay, okay.
So I think time history analysis we can see later or today because I need to check also. These are all things
We
very
can see
old I
later.
did.
We can see later.
Okay, okay then. You got your
So,
STAAD Pro from your company.
no, no, still not an still the PO is under process only.
Oh, okay, okay.
It will take time.
Okay then.
There are
So I can
several
close the
approved.
session for today, right?
Yeah, so next when we can have a class.
Let me know accordingly. Like actually, other classes also there. That's why I forget. So after you texted me today, then only I was referring my old books and all. So that
Okay,
at least I managed to tell you the concepts. Like
okay,
yeah, like that. Like tell me 1 hour before, so that like I will check and I can uh, clarify the other things whatever you asked, moving loads and time history analysis and definitions and all.
okay, okay. So tomorrow we can have our
Okay. Tomorrow at which time?
evening the same 7 o'clock.
Okay, let me
Our
know if I am available, like I can handle.
okay, okay, okay,
Okay then.
okay, okay. Thank you.
Okay, bye.
Bye, bye. Yeah.
So till now you
No,
got all the recordings, like you are getting the recordings or no? Until now.
no, I didn't get. I got only one or two only.
Okay, as a whole, like until now, like or after, I think you said in between, like once you completed totally, you will get also. So let me know if
Yeah,
you want until now, like I can send you. Otherwise, completing after I can send you.
you can send, you can send all once all completed all
Okay,
together.
okay. But like how you are remembering and practicing, right? Until now, whatever we seen.
No, now I will work out. Now I will practice what we
Yeah.
learned
So
today.
today, whatever we seen, these are all things like I never teaching to any students for the past 5 years, 6 years. It was very, very, yeah, before like I know this, but I never teaching these things because since you asked now, that's why I'm referring and again teaching you. So it was not in the
No,
outline. That's why.
no, actually, my intention of this class for this
Yeah, yeah, that you
class.
mentioned, no issue, no issue. Like even I can explore also, na. Yeah, it's fine.
Okay, okay. Because I'm going to have this kind of projects, the blast load
Yeah.
analysis, the EOT crane analysis. So
Okay,
that's why
but
I
like
joined this.
yeah, yeah, but it's fine. Like at least if you can able to manage to get a sample projects, like since you know the software and tools and techniques, so little if
Yeah.
you can refer, then you can work with your new projects like seamlessly. Like
Oh, okay, okay,
yeah, since you know the
okay.
tricks and all, so you know the tricks in the input, how to edit and all, and the sequencing and all.
Yeah, yeah.
Yeah, then like with all this knowledge, you can do well, I think.
No, that's correct. No, but that should that other whatever we learned, I can manage. Apart from that, what I still will not touch that. So I don't know how to if the projects comes how I can manage the time history. Now tomorrow we are going tomorrow or day after we are
Yeah,
going to.
that's why, like, we are going to discuss anyhow. Don't worry. Whatever you ask in the WhatsApp, like, I will clarify you.
Okay, okay, okay,
Yeah.
okay, okay, okay. Thank you.
Okay. Bye.
Bye bye.